Hi everyone. To, Today is the day 3 of DSA of journey. So far we learn of what a DSA in and how LN work, and today we are going to learn of something very exciting. Then searching means of finding something just like you search and for your pencil your and computer also search of for data, and let's begin. Okay, let's start off searching. What is searching? First of all, find a required of element of a collection of data. This is searching of find a required element from a collection of data. Okay. Real life example means imagine your teacher has a list of 50 students name as she want to find your name. Okay. Suppose Rahul C will look through the list one by one, jump to the right place, and this process of find a name that called of searching. And in computers we do the same thing and numbers and data. Okay. And there are, because of two types of there are two types means of search. First of all, linear search and binary search. Okay, check everyone items one by one. Binary search, jump to middle and quit the work of half. Okay, we learn both today step by step. Okay, then step of linear search and binary search. First of all, linear search. Okay, linear search. Define a linear search. Go to the first element. Okay, check every one element one by one, and you till the target of found or the array ends. Example the 10, 20, 30, 40 and 50. Okay, look, the array has 5 number. Okay, we are searching for 40. First step, compare the 10 with 40. Okay, compare the 10 with 40. Okay, yeah, then we can compare to 10 the 40. Now move one step to compare 20 and 40. Okay, to compare to 20 and 40. Okay, it is equal to 40. No, no are equal. Okay, then again move on the step 3, compare of 30 and 40. Compare the 30 and 40 with is equal to no. Move on step 4, compare 40 with 40 is equal to 40. Okay, yes, found at index 3, because in 0 1 2 3 4 found of index 3. Okay, then again, yeah, then again complexity. And now the question of first of this best case of big of 1. What is does the means if the element is that very first position we found out immediately. Okay, there are big of 1. Okay, this suppose a 10 of a number searching, then first element, then a big of 1. Okay, then again only one step. Okay, worst case of big O of n, if the element is at the last position. Okay, we check every single element and step space big O of 1. We do not use extra memory, we just look through. Okay, then array. Okay, then आगे of a binary search. Binary search is a yeah binary search is a smarter way and but is only worked on a sort array. Means number must be ordered small to big. The idea is simple. Look at the middle element. If the target of smaller, search is the left half. If the target is bigger, search the right half. Is way every step cut off the work in half. Okay. Then a real life example. So suppose I thinking a dictionary. Okay. You want to find two word mango. Do you start from page 1? No. Open the middle of the dictionary. Okay. You see word starting with P. Mango comes before P, so you go to the left half. Okay. Open the middle again. You see L mango comes after L, so you go to the right half. In the just a few steps, you the find of mango. This is a binary search. Always cut the work of in half. Okay. Then a number step by step the array 10, 20, 30, 40, 50, 60, 70. Then a target of 60. Okay. Our array has 7 members all in sorted order. We are searching from 60. Okay. First of round 1 full array in left, 10 right. Okay. 10 right. This 10. Okay. Then right. Left equal to 50 right, then 7 middle element of 60 and equal to 60. Yes, found is at index 5. Okay. Then we found 60 in just 2 steps. After insert of checking all 7 element. Okay. Then complexity of best case of big of 1 element is exist at the middle. Found immediately of worst case of big of log n because of partition of this and this. Okay. So because of log n. Okay. After the binary search, take only a 10 step because of 1 extra memory needed. Okay. Then binary search versus linear search. Okay. First of array requirement. Okay. Array requirement is a property of array of needed. Okay. Linear search. First can okay, sorted of unsorted. First, can work on a array sorted or unsorted. Okay. Then binary search must be sorted, otherwise it gives working answer. Okay. Only sorted array and then work of binary search. Best case versus big of 1 first element is the answer. The linear search. Binary search big of 1 middle element is the answer. Worst case linear search big of n check every element. Okay. Then binary search big of n much faster for large data. Okay. Then space of complexity of big of n of linear search, no extra memory, and space complexity of binary search big of 1 no extra memory, same. Then when the use of smaller data and unstorage of data of linear search and binary search large data that is already sorted. Okay. Then one of our real life example of linear search is like a calling every student name by one attendance. Binary search is like open a phone books at a middle jumping to right section for the 10 student. Okay. Right. Both are the fine for the 10 minutes required. Bandit search is the 1,000 items for faster. Okay, then okay. C, best case, worst case, and okay of day 3, and what is searching, then interview questions, difference. Okay, then check and the screenshot of this question, then preparation on interview question. Okay, then last of all, and goodbye and thank you so much